Please consider subscribing after the video if you liked it. Enjoy. This is Sputnik 1, the first artificial satellite ever launched into orbit. It took off on October 4th, 1957, marking one of the most important scientific breakthroughs of the 20th century. From that moment on, humanity looked up and began reaching out. Just a month later, Sputnik 2 carried the first living creature into space. By January 31st, 1958, the United States responded with Explorer 1. And then came the giants, Vostok 1, which sent Yuri Gagarin into orbit, the first human to leave our planet, Apollo 11, which landed us on the moon, and the James Webb Space Telescope, a $10 billion marvel designed to look deeper into the cosmos than ever before. We've been to space. We've looked back at Earth. We've taken pictures that define generations. But you might have noticed something strange. Look at these real space photos. Where are the stars? Why does space often look like this and not like this? To answer that, we first need to understand how cameras work. Every camera has a setting called shutter speed. It controls how long the sensor is exposed to light. The longer it stays open, the more light it captures, the brighter the image becomes. But when astronauts take pictures in space, the subject isn't the stars, it's the spacecraft, the Earth, the astronauts themselves. These are very bright compared to the faint distant stars. So to avoid overexposing the foreground, the camera lowers exposure, and the stars, they vanish into darkness. But with the right settings and enough preparation, we can capture stars, even from space. Now look at this image, taken from Earth with zero light pollution. It's stunning, isn't it? We're told there are billions of stars, billions of galaxies. So why isn't the sky always filled with light? Why does space, the universe itself, feel so dark? The answer lies in the nature of light, distance, and the age of the universe. Light travels, yes, but not forever. It fades, it stretches, it warps with time. And in the vast expanding fabric of space-time, sometimes it disappears. To understand how big the distances are in space, I am going to let you watch an animation about the actual position of the Voyager 1 spacecraft, launched on September 5th, 1977, traveling at about 61,000 kilometers per hour without being slowed down by anything. This is the closest star from Earth, besides our Sun, Proxima Centauri. It is at about 4.24 light-years away from Earth. It will take Voyager 1, with a constant speed of 61,000 kilometers per hour, 77,000 years to reach the nearest star to Earth. Now, imagine that some galaxies are moving away from us faster than the speed of light due to the expansion of space. Their light becomes red-shifted beyond what we can see, pushed into invisible wavelengths. That light is lost forever, not because it doesn't exist, but because we simply can't reach it anymore. So the darkness you see is not empty. It's full of light we can no longer detect. And that's the truth. Space is not truly dark. We are just small, living in a shadowed corner of a glowing universe, still waiting to be understood.